Hi friends, welcome to Shashi Tutorials. Now this is the second chapter in the series of learning the base SAS. Now in today's tutorial we'll be looking at writing the first SAS program. Now we'll start off with a very simple program to read raw data and produce a report. Now let's start out. Now the task that we have is you have a data value in a txt file, and I have taken this txt file here. In this txt file you have the values represented in gender, which is either male or female, then age, then you have height, and you have weight. Now each data value is separated from the next by one or more blanks. Now you want to produce two reports, one showing the frequency for gender, how many males and females, then the other showing the average age, height and weight for all the subjects. Now here in this program, we'll start by the data statement. Data demographics, then we'll write the in file, which is the location of the data file. For me it is C drive and the learn folder. And the data file name is mydata.txt. Now we'll look at input the data, which is input gender, $age, height, weight, then run. Then we'll look at the report. Title, gender, frequencies, proc, frequency, let me make it small, frequency, data equal to demographics, sorry, it is graphic. Let me make that graphic. Then tables, gender, and then the run statement. The next report is title will be summary stats, and proc means data equal to demographic the variables that we'll consider is age, height, and weight. And then we'll finish by putting the run statement. So let me first explain the program to you. Now notice that this program consists of one data step, and then it is followed by two proc steps. Now, as we mentioned in my last tutorial, which was the basic introduction, the data step begins with the word data. And in this program, the name of the SAS dataset we are creating is demographic. Then the next line is the infile statement, which tells the SAS where the data values are coming from, and in this example the text file is mydata.txt, which is in the folder of C drive and in the learn folder on a Windows system. Now if you decide to run some of my programs which I have mentioned here, it is always good that you put all the programs in a better place where you can remember, and this can be any folder of your choice. Now for this I have placed in the learn folder, so I remember it, referencing it all in my infile statement in a proper way. You can put it in any folder you can you like, and you can name it any way. Now the input statement shown here is one of the 4 different type of methods that the SAS has for reading raw data. And this program uses the list input method, appropriate for data values which are separated by delimiters. Now the default data delimiter for SAS is blank. SAS can also read separate data by any other delimiter. So it can read data separated by any other delimiter. For example, commas or tabs with a very minor change to the infile statement. Now, when you use a list input method for reading data, you need to list only the names you want to give to each data value. Now, SAS calls these variables names. Now, also you would have noticed that there is $sign, which is following the variable name here, so the gender. Now the $sign following any variable name tells SAS that the value for those variables are stored as character values. Without a $sign, SAS assumes value are numbers and should be stored as SAS numeric values. Finally, the data step ends with a run statement. Now you would see that depending on the platform, what platform you are running your SAS program, the run statements are not always necessary. Now you will also see the statement in many of my programs, which is title. Title is basically a keyword which is placed in single or double quotes or even no quotes, as long as the title doesn't contain any single quote. Okay. So and it is printed at each of the each pages of the SAS output. Now such such statements or statements such as title statements are called as global statements. Now the term global refers to the fact that operations these statements perform are not tied to a single data or a proc step. The effect they affect the entire SAS environment. Now, in addition, the operation performed by the global statement remains in effect until they are changed. Now, for example, if you have a single title statement in the beginning of your program, that that title will head in every page of output from that point until a new title statement is being placed. Now, it's a good practice to place a title statement before every procedure that produces an output to make it easy for someone to read and understand the information on the page. Now, if you exit your SAS session, these titles are always reset and you need to submit new titles statements if you want them to appear. Now, all the output that I'll be looking at doing in these programs, um, there is a global option also, which is no proc title that would be also in effect. Now, without this option, all output from every procedure would contain text such as the mean procedure before it prints your own title statement. To set this option, the way to set this option is to submit ODS no proc title. So I'll repeat that it's ODS no proc title. Now, proc frequency, let's come to that. Now, proc frequency is one of the many built-in SAS procedures, and as the name implies, this procedure counts the frequency of the data values. Here, to tell this procedure which variable you want to include in your frequency counts, you add an additional statement, the tables. The following word tables, you list those variables for which you want the frequency count. Now, you could actually omit a table statement, but if you did, proc frequency would compute the frequency for every variable in your dataset, and this includes all the numeric variables. Now, proc means is another built-in SAS procedure that computes means, which means averages, as well as some other statistic such as minimum, maximum values for each variable. A variable or a VAR, short form for variable statement, supplies proc means with a list of analysis variables which must be numeric for which you want to compute these statistics. Now, without a var statement, proc means compute statistics on every numerical variable in your dataset. Now, depending on whether you are using a SAS display manager on a Windows operating system or a SAS enterprise guide or a SAS studio, the mechanics of submitting your programs may differ slightly, but all everywhere you would see that you can find the execute button would be a similar icon of a running man or a submit button which has been placed. Now, if we look at the whole environment, the SAS windowing environment, you write the whole program in a SAS enhanced editor. This is known as a SAS enhanced editor window. The other windows that you'll see is basically the log window, and you see a output window where you see the results. Now, at the top you see there is a submit button here, which would help you to run the program that you are putting in the SAS environment. Now, to run the program, what we'll do is we'll select the whole program here and we'll click the run button. So this is the output. Now once, if you see the whole output, and let's understand the top part of the output, which is produced by the prop frequency. Shows here it has two females and three males, and you have 40% as total. Then here you have 60% as the total cumulative frequencies. Okay, so there are the cumulative percentage columns, which shows the cumulative counts as percentage, and so these are the basic output that you would be seeing in most of when you use the frequency procedure. Now, below the frequency procedure, you see the summary statistics for the three numeric variables, and these are produced by the prop means. Now, n is the number of non-missing values, which is here, and mean is the arithmetic mean, and you have the standard deviation, which is there. Then you have minimum and the maximum, which are the smallest non-missing values and the largest respectively. Now if you notice that the two title corresponds to the text you have placed in the title statement, these two. You can also switch among the three windows tabs just by clicking in the below here. Okay, so I'll just resize these, increase this window so that you can see all the three windows. Now if we look at inspecting the log window, now this is the log window. There are a few things that are very important. If you see any error messages here, those would come up and you need to identify them, and then you need to correct them. Now let's spend some moment over the log, and first you see that my data.txt would be there in the top, which is here. Now this is located and it is shown in the file, which is learn my data. Now next you see a note showing that 5 record lines has been read of the data which has been read, and then the shortest line was of 11 characters and the longest is of 13 characters. The next note indicates that the SAS created a data set called work.demographics. Here, then the demographics part makes sense because that's the name that you have used in the data statement. The work part is the way of SAS telling you that this is a temporary data set, and when you end the session this data will self-destruct. You can always make this data permanent, and we'll check that out later how to make this as dataset permanent. So also you will see that work.demographics dataset has 5 observations and 4 variables. The SAS terms observation is very analogous to the rows in the table, and then the SAS term variables is analogous to the term columns, analogous to the columns in the table. Now, in this example, each observation corresponds to the data collected on each subject, and each variable corresponds to each information that you have collected on the subject. Then you have some real-time CPU usage, which is being mentioned. Now, that's the base program that we have written. Now let's look at enhancing this program a little bit. Now at this point it would be a good idea to access SAS somewhere and enter this program if you have installed it. Okay, now let's enhance the program and you can learn some more about how SAS works. Now what we would be doing is we'll be looking at a few more basic operations here. Just a sec. Now what we can do is I'll just copy the set file up till the gender part here, paste it here. What I'm going to do is I'll be looking at a BMI index, which would be BMI equal to, in brackets, weight by let's say 2.2. Okay, let me give you some space so that it's much more readable, and divided by height into 0.0254 and raise it to the power let's run this. Okay, now we can always use asterisks to comment out and show that okay, there are certain comment statements we can put in this program. Now let's understand the program. Now the statement what I've used here, BMI equal to, is called an assignment statement. Now it's an instruction to it's an instruction to perform the computation on the right hand side of the equal sign and assign the resulting value of the variable named on the left hand side. Now in this example you are creating a new variable named as BMI that is defined as a person's weight, and it is divided by the person's height, and which is squared. Now the BMI is a useful index of obesity. If you know, medical researchers often used a BMI when computing health risk of various diseases. Now the assignment statement that uses now this particular assignment statement it uses 3 of the basic arithmetic operators which is used by SAS. Now these operators as the forward slash, as you see there in the equations, now forward slash for division, and the asterisk for multiplication, and the double asterisk for exponentiation. This is a good time to to maintain or to make yourself aware of what are the various operators which are there in SAS. So if I'll repeat that, it is a plus sign for addition, and priority wise it has the lowest priority, then the subtraction which has the lowest priority again, then we have the multiplication which is the next highest priority, then you have the division with the next highest priority. After that comes the exponentiation, which is the highest priority, followed by the negation, which follows the highest in terms of the priorities. And it will be the same algebraic operations order that you have learned in school that apply in various SAS arithmetic operators. Okay, now that would be more on the operators part. Now let's look at maybe a bit more about how do we provide a comment in the statement. So currently this is a statement that we have written. Now imagine if you want to put a comment in between this. So what you have to do is just type in slash with an asterisk mark, and let's see, age in years, an asterisk and a slash mark. So this is how you could write a SAS statement, and you can add a comment in between them. Now so that would be, and there are various commenting styles that people follow. You can really make out your own commenting style and follow it uniformly. Now if we understand how the whole SAS works, there are something I wanted to explain you about. If let's consider the black box of the SAS, how does the whole thing work? Now SAS recognizes the keyboard data, and it understands that it needs to process a data step. Now, in the compile stage, it does some important housekeeping task. Now, first, it prepares an area to store the data SAS dataset, which is demographics. Then it checks the input file, which is described as in the infile statement, and then determines the various attributes of this file, such as the length of the record, etc. Then next it sets aside a place in the memory called as the input buffer, where it places each record of the data, or each line of the data, as it reads from the input file. It then reads each line of the program and checks for the invalid syntax, and determines the name of all the variables that are in each line of the each line in the data set. Now depending on your input statement or the other SAS statements, SAS determines whether each variable is a character or a numeric, and then stores the length for each variable. Now this information is called the descriptive portion of the data set. Now in this compiled stage, now no data is read from the input file, and no logical statement are evaluated. Each line is processed in order from top to the bottom and left to right. So in the current example, you see there are 4 variables which are listed in the input statement. To make it more clear, I'll just remove this. Now, as I was mentioning, there are 4 variables which are listed in the input statement, and SAS sees and decides that gender is a character because there is a dollar sign in front of the name. There is a dollar sign following the name, and then sets the storage length of each of these variables. Because no length are specified by the program, each variable is given a default length, which is 8 bytes for character and numeric variables. Now, 8 bytes for a character variable means you can store values with up to 8 characters. Now, 8 bytes for numeric variable means that the SAS can store number with approximately 14 or 15 significant figures, now depending on the operating system as well. Now, it is important to realize that 8 bytes used to store a numeric values doesn't limit you to the number of 8 digits. The information about each of the variables is stored in a reserve area of memory, which is called the program data vector, or the PDV for short. Now think the PDV as a set of post office boxes with one box per variable and information affixed to each box showing the variable name, type, and the storage length. Now some additional piece of information are also stored in each variable, and we'll be discussing those later in our advanced programming techniques. Um, okay, now let's discuss more on our next chapters and there you would be looking at some more advanced programming. So till then, thank you, and I'll be talking to you in my next series.